Hello viewers. So in this video we're going to look at the quadratic patterns. Okay, now we're going to look at the patterns that are in the form of term number n will be given by n squared plus b n plus c. Okay, now let's check our first four terms of the quadratic patterns. Let's start with term number 1. When our n equals to 1, we get a into 1 squared plus b into 1 plus c. This is just a plus b plus c. Because 1 squared, that is 1. 1 times a is a. B multiplied by 1 as well is just a b, and then plus c. So our first term for quadratic is given by a plus b plus c. This is our first term. Let's look at our second term. We replace this 1 with 2. Okay, we plug when n is 2, we have 2 there and 2 there. So we have, this is 4, this will be 4, and this will be 2b. So we have our second term as 4a plus 2b plus c. And then let's look at our third term. Let's look at it when n is 3. We have our a 3 squared plus b into 3 plus c. We replace every n with 3, okay? Term number 3, when n is 3. So we have 9a plus 3b plus c, okay? So our third term is given by 9a plus 3b plus c. Okay, now when our n is 4, what we have is we have 16a plus 4b plus c. So our fourth term will be 16a plus 4b plus c, and so on. Okay, so this is how the quadratic pattern is being formed. Now, that's why when you solve problems, we always take the first term of that quadratic pattern to be this value, a plus b plus c, to solve for a and b and c. Okay, now let's look at our first difference. Our first difference, that is our linear pattern. You'll see it forms a linear pattern in the way that when we subtract the second term, we say second term minus first term, and then third term minus second term, and then fourth term minus the third term, and so on. You are going to produce a linear pattern. Let's check it out. Okay, we have 4a minus a, that is just 3a. 2b minus b is just plus b. C minus c is just 0. We don't write that one down, so we just, this is our first term of the first difference. First term of the first difference of the quadratic pattern. Okay, now we have third term minus the second term. 9a minus 4a, that is 5a. 3b minus 2b, that is plus b. C minus c, it goes away as well. So this is our second term of our first difference. Okay, now let's go to the third term. How do we get a third term? We say we subtract the fourth term of the quadratic. Fourth term of the quadratic minus the third term of the quadratic. We get 16a minus 9a. You get 7a. And then you say 4b minus 3b, that is plus b, and so on. You proceed like that and so on. Okay, now here, this one, that's why we always take our first term of the first difference to be 3a plus b. This means you can solve for a, b, and c not using only these ones. You can also use 5a plus b. You can also use 7a plus b when you are using the third term of the first difference in a quadratic pattern. Okay, now let's look at our second difference. Our second difference is given by when we subtract these terms of the first difference. So we say the second term of the first difference minus the first term. So we have 5a minus 3a, that is just 2a. B minus b goes away, it falls away, so it just 0. 7a minus 5a, that is again 2a, and then and so on. You see, it is going to form 2a, 2a, 2a. That's why we say it's a constant second difference. It's not just a second difference, it's a constant second difference. Okay, that's why we always take this ones when we're dealing with quadratic. We always take 2a equals to whatever that is here, that is this constant difference. Okay, now let's look at some problems and solve them using the techniques that we learned from this introduction. Let's look at our problem here. Problem number one says consider the quadratic pattern 8, 18, 30, 44, and so on. So for that quadratic pattern, you are going to find the next two terms, okay? What you want to do is we want to write this pattern in our workbook. And then after writing it on our workbook, we want to subtract first term from the second term. We say 18 minus 8, that is 10. 30 minus 18, that will give you 12. 44 minus 30, that will give you 14. And then so and so forth like that, okay? Now, we want to subtract again. We can see we are adding two, but to make sure, just do it for the sake of being safe. You do 12 minus 10 is 2. 14 minus 12 is again 2. So that our constant second difference is 2, 2, 2, 2, 2. Okay. Now what we want to do is we want to add another 2. 2 times 2 here. And now we want to find our next two terms. We say 14 plus 2. We get whatever that we get. We're going to say that number plus 2 again. Okay. Now let's see what we get. We say we get 14 plus 2 is 16. We write 16 there. And then we write 16 plus 2 is 18. We write 18 there. And then so forth. We are not done. We have to find the two terms that will be here and there. Okay. We want to add 44 and 16 to get our next term here, that will be 4 plus 6, 10. So we have 0, and then 5, we have 6 there, 60. So we have 60 there, and we have 60 plus 18 to get our next term, that is 78. Okay, so we have 78 like that. And then we have these two answers as the answers that they are looking for. Just write, okay, our next two terms are 60 and 78 and so on, but they are looking for only these two. Okay, so you are done answering the question. Now our 1.2 says find the nth term of the sequence. Now we are looking for a, b, and c, because we want to write Tn as a n squared plus b n plus c. So this is supposed to be a squared. Okay, now we are looking for a, b, and c. What we can do first is to find a, because we have our 2a here. This is our 2a. This 2 represents our 2a. Remember, in the quadratic pattern in the introduction, we said that is our 2a. So we just write 2a equal to 2. This will imply that your a is 1. When you divide both sides by 2, you get a as 1. Okay. After finding a as 1, now we are targeting our b. We are looking for our b. We can write here that our 3a plus b is going to be 10. 3a plus b is represented by this term that is there. So it's 10, just 10. Remember, it's our first term of the first difference. Or you can take the second term of the first difference as well, but now you're not going to say 3a plus b. You're going to say 5a plus b should give you 12. Okay, this one here. Now let's proceed. We have our 3 times a is 1, so it's just 3 times 1 is 3 plus b, that is 10. So our b is 10 minus 3, that is 7. Okay, or you can say from this side b is 12 minus 5 into a is 1. So you have just 12 minus 5, and then this will give you 7 as well. So our B is 7. Okay, now let's look for our C. How we get our C is we're going to say A plus B plus C is equals to the first term of the quadratic pattern, that is 8. So we just write 8, the 8 there. Or you can say 4A plus 2B plus C is 18. We'll get the very same answer as well. Okay, but we don't want, it's a lot of work with those ones. So with these ones that are just A plus B plus C is equals to 8, we can just proceed and find the answer. A is 1, B is 7, plus C is 8. So 8 plus C should give you 8. This means C should be nothing. So that 8 equals to 8. So after finding the value of C, what we want to do is we want to write that our answer for Tn is Tn equals to A is 1n squared plus B plus 7 n, and then plus C, that is 0. So this is our answer. Tn is given by n squared plus 7n. Okay, if you want to test it, here's what you can do. You just write term number, you choose any one, maybe 1 or 2, 3 or 4. Let's choose 3 for this sake. Okay, let's choose term number 3. We say we're going to write term number 3 is going to be 3 all squared. We are substituting every place when we see n, we plug n. We plug our n, that is 3 in this case. So that is 7 times 3. This should give you 9 plus 21. 9 plus 21 is 30. And then this is true. This confirms that this general term, that is this one here, will work for this quadratic pattern that is given, that is 8, 18, 30, 44, and so on. Okay. Right, now that we know our nth term, what we can do is we can just go ahead and answer question number 1.3 that says, which term n of the sequence is 330? Okay, now what we're going to do there is we just write 330 equals to our an squared plus bn plus c. Okay, let's proceed. So we write 330 equals to our a is 1 n squared plus b is 7n, and then plus c, that is just 0. After writing it like this, we just solve the quadratic equation that we are dealing with now, because it's what we are facing. So we just say n squared plus 7n minus 330. This will be equal to 0. I took the 330, we take it to the other side. Okay, now after we do it like this, because we have this big magnitude here, 330, the easy way to go to the answer is to use the quadratic equation and say n equals to minus b plus minus the square root of b squared minus 4ac. Okay, and then divided by 2a. After writing it like this, our next step is to just replace a, b, and c with 1, 7, and minus 330. Okay, now we say this will be equal to minus b is 7 plus minus the square root of b squared, that is 7 squared. Just write 7 all squared minus 4a is 1. Our c is minus 330, and then we close the bracket. And then we divide everything by 2. Our a is just 1. Okay, and then from here we just say this answer is going to be minus 7 plus minus the square root of this value is 1369. So 1369, we plug it there, and then we divide everything by 2a. That is just 1. We are fine. Okay. After this step, we just write our n is going to be equal to minus 7 plus the square root of 1369 is nothing but 37. And then we divide by 2, or our other n is going to be minus 7 minus 37 over 2. Remember, we are dealing with quadratic, so we have to produce two solutions like this. So we have here 37 minus 7. That is minus 7 plus 37. You get positive 30 divided by 2, you get 15. So we write 15 here. And then our n, our other n is equals to, this one we cannot take, it's negative. We have negative 37 minus 7. That is minus 44. Divide by 2, we get negative 22. Remember, our n cannot be negative, so for this one we write no solution. This one is indeed our solution. Okay, now those are the answers to this question. Let's look at the next question. So the next question says, given that the quadratic pattern is minus 3, 4, x, 30, and so on, find the value of x. Okay, for this one, what you can do is we are going to rewrite this quadratic pattern into our worksheet. That is minus 3, 4, x, 30, and so on. And then we say 4 minus negative 3. That is 4 plus 3. That will give us 7, positive 7. And then the next term is we have x minus 4. So we plug it as x minus 4 there. And then we have 30 minus x. So we write 30 minus x there. This is our first difference. Okay, this is our first difference, and then we want to find our second difference. After finding our second difference, what we can do is we can equate them. Why? Because remember, our second difference for a quadratic pattern is constant, is the same. Each term that will be here, they will be the same. Okay, now that's what we want to do. We want to say x minus 4 minus 7. This will be x minus 4 minus 7 is minus 11. And then we write our next term, that is 30 minus x minus 4. So we have 30 minus negative 4, that is 30 plus 4, 34. And then we have x, that is negative x here, negative x minus this x, that is minus 2x. Okay, and then from here what we can do is we can just equate the two second differences. Remember, this is our second difference. Okay, now we can just equate them and say x minus 11 is therefore equal to 34 minus 2x. Why? Remember, on the second difference at the beginning of this video, we had 2a, 2a. These ones, we know they're going to remain 2a's. You see, all of them, 2a, all of them. The ones at the second difference, the last step, when we subtract for the last time. Remember at the beginning of this video, okay? Now from here we just solve for x. That will be x plus 2x. We say this x, we take this 2x to the other side. That will be plus 2x plus 2x. This will be equal to 34. This negative 11, we take it to the other side. It will be plus 11. Okay, and then here we have 3x equal to 45. 3x equal to 45. From here we just divide by 3 both sides, so that we have x equals to 45 over 3. 45 divided by 3, this is just 15. And then you can go back and test it, that if x is 15, is this true? Okay, is minus 3, 4, x, and 30. Let's see. So we have minus 3, we have 4, we have 15, that is our x, we have 30, and then so on. Okay, now we just want to test it if this is true, if 15 is the best candidate for this position of x. Okay, now 4 minus 3x, that is 7, we saw. Just so this one is 7, this one is 15 minus 4, this one is 11, and then 30 minus 15 is just 15, and then so on. This is our second difference. It forms a linear pattern, it forms a arithmetic pattern. Okay, now here we have 11 minus 7, this is just 4. 15 minus 11 is just 4 again. You see, it is the best candidate because it does what? 4, 4, 4, 4, and so on. Okay, so many fours, and this is the best candidate for this solution. And if you're looking for more videos like this, please be sure that you subscribe to this channel, like the video that you are watching, and share this video with your friends. Okay, and so question number 3 says, for the quadratic pattern minus 3 minus 2 minus 3 minus 6 and so on, find the nth term of this sequence. Okay, so we want to find our a, b, and c first. So we just rewrite it as it is: minus 3 minus 2 minus 3 minus 6 and so on. Okay, so we say minus 2 minus negative 3, that is minus 2 plus 3, that is just positive 1, minus 3 minus negative 2, that is minus 3 plus 2, so that just tends to be minus 1. And then we have here minus 6 plus 3, that is minus 3, and then we have this linear pattern going on and so forth. So we have here again minus 1 minus 1, that is just minus 2, and then we have minus 3 minus negative 1, that is minus 3 plus 1, that is just minus 2 again, and then so forth. Okay, remember this one will remain minus 2 minus 2 minus 2 and so forth. Okay, now one thing to remember is that we equate it to 2a. In the beginning of this video, when we introduce the quadratic patterns, remember this part here of the quadratic pattern, this part that is, we call it a second difference of a quadratic pattern, is always 2a. So we just write 2a equals to minus 2, and then our a will therefore be minus 1. So we have our a as minus 1. Let's find our b. We can use 5a plus b as minus 1, or 3a plus b as 1. Let's use 5a plus b as minus 1. Remember, this one here is the second term of the first difference. So we have minus 1 here as our second term of the first difference. Okay, or like I'm saying, we can just again use 3a plus b as 1. This one here, the positive one there, is our first term of the first difference. We'll still get the same answer. This one gives us our b as minus 1. We subtract 5a minus 5. A is minus 1, so minus 1 times this minus 5 is just going to be that, and this will produce your b as positive 4. Same applies to this side. We have b equals to 1. We want to subtract 3a. A is minus 1, it will turn this minus to positive, and this will be again 4. You see, b is 4 in both cases, and so our b is just 4. Let's find our c. We can just use a plus b plus c as what? Let's see. The first term of the quadratic pattern is just minus 3. Okay, now we have c being equal to minus 3, that we subtract negative 1. Minus negative 1 tends to be positive 1. And then we also subtract b. When it comes to this side, it was positive, that side it must be negative. So we subtract b. Subtract what? We subtract a positive 4. So we subtract a positive 4. The answer for this one will be minus 3 minus 4, that is minus 7, plus 1, that is just minus 6. So our c is nothing but minus 6. Okay, now let's write our general term. That our general term Tn will be a n squared, that is minus 1 n squared, and then we have plus bn, that is plus 4n, and then we have minus 6, like the first one that we did, like the second one after introduction that we did. We tested it. We can just test this one as well. It will also give you the correct solution. So this is our solution to 3.1. 3.1 was saying find the nth term. Now we want to find the first difference between the 35th term and the 36th term of the quadratic pattern. Okay, be careful with this one. What they want is the first difference. They want part of this sequence that is going on here, but they want somewhere there in the fourth, when we have the term number 35 here and term number 36 somewhere there. The difference between them, they want that term of this pattern going on here. Okay, let's go and find it. So you must know that linear term or arithmetic term number 35 is equal to quadratic term number 36 minus quadratic term number 35. The pattern that we are doing here, the same sequence that we are doing here, we will be following it when we reach there in the front. Ne? So we have here linear number 35 being equal to quadratic term number 36 minus quadratic term number 35. Okay, is the general term for this thing is linear term number n will be equal to quadratic number n plus 1 minus quadratic number n, or you want to say linear term number n minus 1 is equals to quadratic number n minus quadratic number n minus 1. Okay, so when you put n as 36 here, you will see it's true, it will produce this. Okay, so you have 36 minus 1, 35 there, and then 36 is n, 35 there is 35 here is just this 36 minus 1 here. Okay, or use the second one, it will be true again, but this time we use n as 35, linear number 35, and it works for not for 35 and 36, for 100, for 99, for everyone that will be part of this quadratic pattern, it will work. Okay, now let's proceed and answer the question. The general term that we used said linear term number 35 will be equal to quadratic term number 36, subtract from it quadratic term number 35. So we have here linear term number 35 as equals to quadratic term number 36. Quadratic term number 36 is, we put in bracket, ne? Because of this multiple negative signs, don't make mistakes. And then you're going to put everything on your calculator. We have minus, we write 36, we square, plus 4, we write 36, we close, we subtract 6. This is quadratic term number 36 for you. Okay, now you want to subtract from it. You want to subtract what from it? You want to subtract quadratic term number 35. So quadratic term number 35, we just say is just minus, you write 35, you square everything, you plus 4. This is me rewriting this general term, but with term number 35, okay, and term number 36. We are using it to find those values. Now we have 4 into 35, we subtract the 6, and then we close the bracket. Okay, this one in the first bracket, this one here, it will give you negative 1158. Don't make mistake, press a calculator, you'll find negative 1158, and then you subtract from it negative 1091, and then you close the bracket, and then this is just a negative 1158, negative 1158 plus 1091. This will give us negative 67, negative 67. So this is our final answer. This is the term that they are looking for. It's part of those arithmetic series that is 1 minus 3 and so on. This minus 67 is part of those guys. Okay. Now the last question says 3.3. Explain why, sorry about the spelling there. Explain why this pattern will never contain positive terms. Okay. Let's go and explain why they will never contain a positive terms. So there are many ways to do this one. We say, according to this quadratic, remember quadratic, when you sketch it as a function, quadratic function, it's either is a smiley face or it's a sad face like that. Okay. Now, according to what we have here, this negative a, that is minus 1, our a is negative 1. It will, we are here. Okay. This one, we don't have it. We don't have positive a. If we had positive a, we'll have smiley face. Okay, but now in this case we have negative a. We have we have that one as our function, our quadratic pattern forming that quadratic function there of a set face. Now if it has a set face, you must know it will reach a peak, it will reach a maximum. If we can find that maximum value to be negative, then all these other values that are below it are also negative. If you can only prove that this one here is negative, the y value at the maximum is also negative, we have proven that this pattern will never contain a positive term because the maximum one is also negative and all the other ones that are below it will also be negative. Okay, now we just say that maximum term, the y at the turning point. Okay, we say, you can say the maximum will be, you write it in this form, it's 4, because we are dealing with the quadratic, we can use this knowledge of quadratic patterns or quadratic, anything that has to do with quadratic. You say 4ac minus b squared over 4a. This is the last, this is the coordinates of the turning point of a quadratic pattern are given by minus b over 2a is to this guy here, and then you close. This is the x value. This will be our n. If they wanted to say find the n that will make us to find this term, then we will, you will see we will also use this one and find that term. We will use the minus b over 2a and use it to find this term together with this guy here. Okay, without using these guys, that is 4ac minus 2a. Let's proceed and avoid confusion. Let's proceed. We say that last term is going to be equal to 4 into a is minus 1, c is minus 6, and then we say minus 4 squared. That is over 4a is minus 1. Okay, let's simplify it and see what's the answer. The answer will be, the answer is already here in front of us. This one is the last one. This minus 2, you see it's from negative side, negative 3. And then it reaches minus 2 and it goes back to negative 3 again. And then minus 6 and so on. So this one is the last one. This is the answer that we must get. But let's see if we get that answer. So we have 4 minus, and minus here is minus, is positive. So we have 4 into 6, that is nothing but 24. 24 minus 16, 4 squared is 16. Divide everything by 4. What is 24 minus 16? You have 8. 8, that is over minus 4. Sorry, this is supposed to be minus 4. And this will be minus 2. And this is the minus 2 that I'm talking about. So when you give your answer, you say, and therefore Tn is less but also equals to minus 2. It's going to be minus 2 at some point, and then it will be minus, it will be the ones that are below minus 2 as well. And then you have shown that this one is the last one. Remember, you must first show that this one is the one at the maximum, because since you can say, because you write it like this, the 3 dots facing down, it's because our a is negative. our a is negative, is less than 0, and this one is the last one. That's what you can do. To You have answered the question like that. You show them that your a is negative, is less than 0, because it's minus 1, right? And then the last one is also negative. The last term, the maximum term, is negative. Okay? And then therefore the t ends will be negative because they are below this one. Remember, this one is the maximum, so because since they are below this one, they will all be negative. Okay, the last let me show you the second approach to approach this question. What we can do again is we can say that n at maximum is equals to minus b over 2a. That is, minus b is 4 over 2, a is minus 1. So the n at maximum will be minus 4 over minus 2. This is nothing but term number 2. Term number 2 will be the last one. See, term number 1, term number 2. This negative 2 will be the last one. You found the answer, you can just proceed and give the answer. But if you want to proceed and give them the more valid answer, you say, okay, so term number 2 will be minus 2 squared plus 4 into 2 minus 6, and this will give you minus 4. This will give you minus 4 plus 8 minus 6. This is minus 10 plus 8 is minus 2. So term number 2 is indeed, remember this one here is minus 2, not 2, minus 2. And then that's what we have as our last term. And after writing it like this, you proceed and write this guy here as your final answer. And then you are fine, you are good to go. So number 4 says, given the quadratic pattern 3p, 25, and so on, and again the sequence of the first difference as 9 and q, and the others that we don't know, find p and q. So we want to write it again. We want to write 3p, 25, and so on. But now they're saying when you subtract p and 3, say p minus 3, you will get 9 there. They say you will get 9 because the first term of the sequence, the first difference is 9 there. And then we say 25 minus p. 25 minus p will give us what? It will give us q. And then we will get so on. But we know that 3 minus p is 9. So we can go ahead and solve for p. That p is just, we take p to the other side and 9 to the other side. We just say p is minus 6. 3 minus 9 is 6. So we have p as minus 6. Then we have 3 minus negative 6, that is 3 plus 6, that is 9. Okay, so you have solved for p. Now you have to find 25 minus p. It should give you q. So this means q will be nothing but 25 minus negative 6. This is 25 plus 6. This will give you 31. And these are the answers to number 4. Minus 6 and positive 31. Thanks for watching this video. Please don't forget to share, like, and subscribe to this channel for more videos. Thank you. Bye.